Okay, what we were just doing here on the problem we just got, the last set, we were doing things like this, 2x minus 1 equals 9, and we were squaring both sides. Okay, and I just was saying this and this reduce themselves. Okay, well, why do those reduce themselves? Well, a square and a square root are inverses, so they undo one another. But another thing to remember is, square roots were power 1/2. We could have rewritten that as 2x minus 1 to the power 1/2 equals 9. That would have been the same problem as the square root of 2x minus 1. And really what we're trying to do is get this power 1/2 just to turn to 1. So if I multiply this power times 2, well, if I multiply that power times 2, I have to multiply this power times 2. There was a 9 to the first. So I multiplied a power times 2 and a power times 2. See, 1/2 times 2 makes it 2x minus 1 all to the first equals 81. That's another way to think of why square and square roots cancel out. It's really their powers just went to 1. So if we have fractional powers, we still just want that power to go to 1. I don't really want like a square root and a square. I need something that will undo the 3/2. Well, it's a power. I'm just going to multiply by the power 2/3. If I multiply that by the power 2/3, I got to multiply that by the power 2/3. Now, the 2/3 and the 2/3 just make a power 1, which leaves that p minus 4. And we've got to remember how to do 27 to the 2/3. Here's how I remember it. X to the 1/2 is square root of x. See, the 1 is the number on the inside, and the 2 is the root. So the bottom number is the root. So the bottom number is the root. That means the third root of 27 squared. Okay, I think going down is easier. I need something times something times something is 27. Well, 3 times 3 times 3 is 27. So this whole thing turns into the number 3, and then that square is still on it. So 27 to the third root is the number 3, and then that is squared, so now that whole thing becomes 9. Of course, add 4 to both sides, and we have 13. Okay, so let's do it again on number 2 over here. I need to get rid of the 3/2. I'm going to multiply by 2/3. Multiply by power 2/3. Those two go away, leaving p plus 22 equals 27 to the 2/3. Now we just did that one over there, but I'm going to go through the thought process again. That's the third root of 27 squared. Okay, the third root of 27 is 3, and then that is squared, so that whole thing is 9. Subtract 22 to the other side. So we have p equals negative 13. Okay, number 3 is one like we just did. We can square both sides, but we got some work to do. Before we do that, we've got to add the 4. So I have 29 minus 2x equals 27. Still not ready to square both sides yet, so I got to divide off the 3. So it's really the square root of 29 minus 2x equals 9. Now I can square both sides. So it's like the 1/2 power times power 2. So that's 29 minus 2x now equals 81, and just solve it from there. So subtract the 29 from both sides. 81 minus 29, 52. And divide off the negative 2. So negative 27, 26. 52 divided by 2 is 26. Okay, I'm going to do the same thing, but remember, don't get to the exponents until you have some things cleaned off here. So number 1 is to subtract 10. So subtracting 10 is the same as subtracting 40/4. So I have 41/4 minus 44, so this is going to leave us with 1/4. Okay, now I'm going to divide by 2. or multiply by 1/2 since I got a fraction over here, so I end up with 1/8 over here. Okay, so now I need this to become a positive 1, so I'm going to take the power times -2. Okay, that means I'm going to take this whole side times negative to the power -2. Okay, these go away, which is what I wanted. Okay, this -2 is on the 1 and it's on the 8, so it means it's flipping it upside down. It's making it 8 over 1 to the power +2. So the 1 went downstairs, the 8 went upstairs, and that fixed the negative. So 1/8 to the -2 is really 64. And then just add 22 to both sides. So a negative power, when you get it on something, will just flip over a fraction. If it's on the whole thing, it puts the top part down and the bottom part up. It just essentially turns it over. Okay, before we get to this 4/3, we got to get rid of the -5. So I'm going to divide both sides by -5. 1280 divided by 5 is a negative, and a negative is going to make it positive 256. Okay, I want this 4/3 to become a 1, so I'm going to multiply it by the power 3/4. That means I got to take this one times the power 3/4. So we have 7r minus 6. Okay. Again, the square root of x is x to the 1/2. The 1 is on the inside, so the 3 is on the inside. So it's the 4th root of 256 to the 3rd. Okay, so I need 4 numbers that multiply to 256. So I'm going to guess maybe, I know it's not 3, but here's 3 times 3 times 3 times 3. That's not enough. 4 times 4 times 4 times 4. See, that's 256. 4 numbers that multiply together to be 256, that is the number 4. And then the power is on it still. So 4 to the 3rd is 4 times 4 is 16 times 4, it's 64. 4 times 4 times 4 is 64. So this piece is 64. Add 6 to both sides. So we have 70 equals 7r. Divide by 7, so r is 10. And then number 6, we got to get rid of the 1. So I'll just add 1 to both sides. So really we have the square root of 7 minus v equals 6. Now this one's going to be an easy one. We can just square both sides. So we have 7 minus v equals 36. Subtract 7. Negative v equals 29. So v is negative 29. Okay, so fractional exponents, you're just trying to get that exponent to a 1, so multiply it by whatever it needs to be a 1 and deal with what it does to the other side.